Oppenheimer is remembered as a moment in history when scientists built a bomb and tested it in the desert and helped end a war. That's the story most people know, and it feels like something that happened a long time ago and stayed in the past. But the Trinity Test wasn't just about proving a weapon could work. It was a moment when scientists knowingly conducted an experiment where some consequences would be permanent and where they could not test what would happen to people beforehand. Once they pressed that button, there would be no way to take it back. Something changed that day in the New Mexico desert, and it wasn't just about nuclear weapons. It was about the way discovery itself works, and what scientists are willing to accept as an acceptable risk when the stakes get high enough. And it's still happening right now. What most people think Oppenheimer was about. Most people believe the Trinity Test was about one question, and that question was whether the atomic bomb would actually work. Scientists had spent years developing this weapon, and they needed to know if all of their calculations and engineering would translate into an actual explosion. That's the story we know, and it makes sense, because that was definitely one of the goals. The conventional version goes like this. Scientists gathered in the New Mexico desert on July 16, 1945, and they detonated the first nuclear weapon ever created, and it worked. And it worked beyond their expectations, and then a few weeks later, they used similar bombs on Hiroshima and Nagasaki, and the war ended. A dangerous experiment with a clear goal and a successful outcome. There's even this famous story that gets told about the Trinity Test, and it shows up in movies and documentaries all the time. The story says that right before the explosion, some scientists were worried that the bomb might ignite the Earth's atmosphere and create a chain reaction that would destroy the entire planet. And supposedly, physicist Enrico Fermi was taking bets on whether they were about to end all life on Earth. That story makes Trinity sound incredibly reckless, like scientists were gambling with human extinction. But here's what actually happened with that concern. Back in 1942, physicist Edward Teller raised the question about whether the heat from the bomb could cause nitrogen atoms in the atmosphere to fuse together and create a runaway reaction. It was a legitimate question to ask because they were entering completely unknown territory. So another physicist named Hans Bethe sat down and worked through the mathematics by hand, and he calculated that it was incredibly unlikely, basically impossible. Then Teller himself worked with another scientist named Emil Konopinski, and they wrote detailed papers proving that the atmosphere couldn't ignite no matter how hot the explosion got. This was all resolved 3 years before the Trinity Test ever happened. By the time they were standing in that desert in 1945, the atmosphere question wasn't a real concern anymore. When Fermi was taking bets, it was dark humor. He was mocking the old fear, because everyone knew the calculations had ruled it out. The scientists weren't worried about ending the world. They had done the math, and the math said it wouldn't happen. So if that wasn't the risk, what was? The risk scientists couldn't fully test. The real problem with Trinity wasn't whether the bomb would work or whether it would destroy the atmosphere. The real problem was that they knew the explosion would create massive amounts of radioactive fallout, and they had no way to accurately predict where that fallout would go or what it would do to the people living downwind. Radioactive fallout is what happens when a nuclear explosion vaporizes everything near it and pulls dirt and debris up into the air. And all of that material becomes intensely radioactive, and then it comes back down. The scientists knew this would happen because the basic physics of radioactive contamination was already understood. What they didn't know was how far it would spread, or how dangerous it would be to people who weren't at the test site. Here's what made this different from testing whether the atmosphere would ignite. The atmosphere question was something they could work out with mathematics and physics calculations. They could model the nuclear reactions and determine whether a chain reaction was possible, and they did that, and they got a clear answer. But predicting exactly how radioactive particles would move through the air, depending on wind patterns and weather conditions, and how much radiation different people would be exposed to, depending on where they lived and what they ate and how much time they spent outside, that was vastly more complicated, and there was no way to test it beforehand. You can't do a practice run of exposing civilians to radiation to see what happens. That would be deeply unethical. So the only way to know what the fallout would actually do was to detonate the bomb and watch what happened to real people in real time. The scientists did set up some monitoring equipment, and they did try to track wind patterns, and they did have conversations about the risks. In fact, less than 1 month before the Trinity test, they finally established a team specifically to monitor fallout. Less than 1 month. For context, they had been working on the bomb itself for years, but the team responsible for protecting civilians from radiation was thrown together at the last minute. They also discussed evacuating nearby towns. There were ranches and farms all around the test site, and small communities within 50 miles and thousands of people who had no idea what was about to happen. The Manhattan Project was top secret, so none of these civilians had been warned that a nuclear test was coming. Scientists talked about whether they should evacuate people just to be safe. They decided not to. The official reason was that evacuations would compromise secrecy. The unofficial reason was that there was enormous political pressure to conduct the test before July 17th, because that's when President Truman was meeting with Stalin and Churchill at the Potsdam Conference. Truman wanted to know if the bomb worked before he had to negotiate the end of World War II. The political deadline took priority over protecting civilians from an experiment that had never been done before, so they made a choice. They chose to proceed with an experiment where they knew radiation would spread to populated areas, and they couldn't predict exactly how dangerous it would be, and they couldn't take it back once it happened. This wasn't scientists being reckless or stupid. This was scientists and military leaders deciding that the potential benefits outweighed the risks to people who didn't even know they were part of an experiment. And that's what made Trinity fundamentally different. It was the first time that scientific discovery crossed into territory where you couldn't test the consequences safely first. What the test actually revealed. The bomb detonated at 5:29 in the morning on July 16, 1945. The explosion created a fireball that rose 60,000 feet into the atmosphere, much higher than scientists had predicted. All of that height meant the radioactive cloud traveled much further than anyone had calculated. Within hours, radioactive ash began falling from the sky. 50 miles away in a town called Ruidoso, there was a group of teenage campers, and white flakes started falling on them. The flakes looked like snow, but they were hot, and the children played in them because they didn't know any better. In the years that followed, several of those campers developed serious illnesses, and many did not live to old age. Their story has been cited for decades by researchers and advocates studying Trinity fallout. In Tularosa, also about 50 miles from the test site, families found ash covering everything. One woman named Tina Cordova later reported that 6 members of her immediate family developed cancer after the Trinity test. Similar stories emerged all across the region. 5 days after the explosion, scientist Stafford Warren reported that there was a very serious hazard over 2,700 square miles downwind from the test. The fallout had been much more dangerous than their predictions suggested, and they had exposed thousands of civilians to harmful radiation levels. The New Mexico Department of Health later showed that infant mortality rates spiked dramatically in 1945. The rate jumped to 100.8 deaths per 1,000 live births, compared to 89.1 in 1944, and then dropped back to 78.2 in 1946. That spike lines up exactly with the Trinity test. Scientists eventually tracked radioactive particles from Trinity across 46 of the 48 contiguous United States. One explosion in a remote desert had spread contamination across most of North America. The scientists weren't surprised that there was fallout. What surprised them was how far it went and how wrong their predictions had been. They had tried to calculate the risks, but the actual consequences were much worse than they anticipated. By the time they learned this, it was too late. The radiation had already fallen. The people had already been exposed. The damage was permanent. The first experiment. You couldn't undo. This is what separated Trinity from everything that came before it in the history of science. For most of human history, scientific experiments had been reversible. If you tested a new chemical reaction and it went wrong, you could clean up the lab and try again. If you built a bridge using a new design and it collapsed, you could analyze what failed and build it better next time. Even dangerous experiments usually affected a limited area and a limited number of people. Trinity broke that pattern. Once the bomb detonated, there was no way to reverse what happened. The radioactive particles couldn't be called back. The exposure couldn't be undone. The people who were contaminated would carry that radiation in their bodies for the rest of their lives. Some researchers later raised concerns about possible long-term genetic effects, though the full extent is still debated. The scientists knew this going in. That's the crucial part. They understood that this wasn't a test where they could stop midway if things went wrong or clean up afterwards if the results were bad. They were making a one-way decision that would have permanent consequences for thousands of people who had no say in whether the experiment happened. And they made that decision anyway because the alternative was waiting. Waiting would have meant missing the Potsdam deadline. Waiting would have meant not knowing if the bomb worked when Truman sat down with Stalin. Waiting would have meant giving up a strategic advantage in the final days of World War II. The pressure to move forward was enormous, and the risks to civilians became acceptable losses in that calculation. This created a new category of scientific experiment. Before Trinity, you could argue that science was fundamentally about learning and discovery, and that even dangerous experiments could be justified because we were gaining knowledge. But Trinity introduced something different. It introduced experiments where the price of knowledge was paid by people who didn't consent and couldn't be compensated and couldn't ever be made whole again. The civilians downwind from Trinity weren't volunteers. They weren't soldiers. They weren't even informed that the test was happening. They were just people who happened to live in the wrong place at the wrong time, and they became permanent casualties of an experiment they never knew they were part of. To this day, those people and their descendants are still fighting for recognition. In 1990, Congress passed the Radiation Exposure Compensation Act, which provided financial compensation for people exposed to radiation from nuclear testing in Nevada. But the law specifically excluded the New Mexico downwinders from Trinity. Even though Trinity was called one of the dirtiest American nuclear tests, and even though the fallout spread further than any other continental test, the people it affected were left out of the compensation program. They're still trying to get included. As of 2024, there are still active efforts in Congress to add Trinity downwinders to the list of people who deserve recognition and compensation for what was done to them. But for many of them, it's too late. The damage happened 80 years ago, and a lot of those people are already dead. That's what it means for an experiment to be irreversible. How this changed scientific discovery. After Trinity, the nature of scientific research began to shift. Scientists and governments started to realize that some discoveries came with consequences that couldn't be tested safely first and couldn't be reversed if they went wrong. And once they crossed that line, they had to decide whether gaining the knowledge was worth the permanent cost. This affected how nuclear research continued. After Trinity, there were hundreds more nuclear tests, and some of them were even more careless about civilian exposure. The Nevada test site conducted atmospheric tests throughout the 1950s, and those tests created widespread fallout that affected communities across the western United States. Eventually, the government did start evacuating people and monitoring radiation more carefully, but only after decades of damage had been done. But the impact went beyond nuclear weapons. The Trinity moment, this idea that some experiments can't be undone, started appearing in other fields of science. Genetic engineering raised similar questions. If you release a genetically modified organism into the environment and it reproduces and spreads, you can't recall it. If it causes unexpected harm, there's no way to put it back in the lab. Climate engineering proposals have the same problem. If you try to cool the planet by releasing particles into the atmosphere to block sunlight, and it causes unforeseen weather patterns or crop failures, you can't reverse it quickly. The particles stay up there. The consequences play out. You learn by doing, and by the time you know if it worked, it's too late to choose differently. And then there's artificial intelligence, which is happening right now. In December 2024, the Future of Life Institute released their AI Safety Index, and they evaluated the major companies racing to build artificial general intelligence. These are systems that would match or exceed human intelligence. Every single company scored a D or worse on existential safety planning. Not one of them has published a detailed, credible plan for how they would control an AI system that becomes smarter than humans. These companies claim they'll achieve this within the next 2 to 5 years, and they're building these systems without being able to test whether they can keep them safe before deployment. You can't run a practice version of artificial general intelligence to see if your safety measures work, because by definition, the test version would be the real thing. So they're in the same situation as the Trinity scientists. They can make predictions and run calculations and hope they're right, but they won't know for sure until it's already live and running, and at that point, it's too late to take it back if something goes wrong. The same pattern shows up in gain-of-function research. This is where scientists take existing viruses and modify them to be more transmissible or more deadly in order to study how pandemics might emerge. The research is supposed to help us prepare for future outbreaks, but if one of those modified viruses escapes from a lab, it could start a pandemic that kills millions of people. And you can't test whether your safety protocols are good enough without actually creating the dangerous virus first. On May the 5th, 2025, just a few weeks ago, the Trump administration issued an executive order restricting federal funding for gain-of-function research because of these concerns. The order specifically cited worries that the COVID-19 pandemic might have originated from a lab leak in China. Whether that's true or not, the debate highlights the same problem. Scientists create something dangerous because they believe the knowledge is valuable, but they can't know if it will escape until after it already exists. This is the world that Trinity created, a world where some of the most important and potentially most dangerous research requires proceeding without complete knowledge, where scientists have to make one-way decisions and accept that they won't know if they were right until it's too late to choose differently. What system are you already in? Oppenheimer is remembered as a historical figure who built the atomic bomb, and the Trinity Test is remembered as a moment when that bomb was proven to work. But what really happened that day in the New Mexico desert was that science crossed a line. It moved from experiments that could be tested and reversed and controlled into experiments where the consequences were permanent, and the people affected had no choice and no warning. The scientists who stood in that desert in 1945 knew they were making history. What they might not have fully understood was that they were also setting a precedent. They were demonstrating that when the pressure is high enough and the stakes seem important enough, it becomes acceptable to proceed with experiments that can't be undone and to pay the price with other people's lives and futures. That precedent is still being used today. Right now, companies are racing to build artificial intelligence systems that could be more intelligent than humans, and they're doing it without concrete plans for keeping those systems under control. Right now, scientists are creating modified viruses that could start pandemics, and they're doing it because they believe the research will help us. But they're creating the danger first and hoping the safety measures hold. And just like the people downwind from Trinity, most of us won't know we're part of these experiments until the consequences are already unfolding. So here's the question that matters. Oppenheimer marked the moment when science could no longer promise that experiments were safe, that the pursuit of knowledge had entered territory where some discoveries come with permanent, irreversible costs that get paid by people who never agreed to take the risk. Do you think science can ever return to a point where experiments feel truly safe again? Or has that line already been crossed too many times to go back? And maybe more importantly, what experiments are happening right now that you're already part of without even knowing it? If you found this interesting, consider liking the video and sharing it with someone who enjoys thinking about how discovery really works.